So, hello everyone. Welcome to the Health and Wellness Show. Today is Friday, December the 16th, and joining me in our virtual studio from all across the planet is Elliot and Erica. And Gabby, Doug, and Jonathan are missing in action today, but we'll catch up with them. By the way, I'm your host, Tiffany. So today we have a very special guest. We actually had him on the show last year. The name of that show was A Conversation with Jack Kruse. So I would highly advise you, if you haven't listened to or read the transcript to that show, to go back and do that, because it was packed full of information that will burst your head open. So Jack Kruse is with us today. He's a respected neurosurgeon. He practices in the Gulf South. He has a monster blog called jackkruse.com. He is the progenitor of the Leptin protocol and the cold thermogenesis protocol. So he is back with us today. We're going to kind of pick up where we left off last time, talk about some new things. So on the last show, we talked about your background, Dr. Kruse, the leptin protocol, cold thermogenesis, the importance of DHA in the diet, and the importance of purple light from the sun, among other things. We wanted to talk to you about the Quantlet, since the Quantlet has made its debut. Can you tell us more about that? Because we didn't really have a chance to get into it on the last show.
Sure. The Quantlet was an idea that I've had for quite a long time, and my idea for it was significantly different than some other people that were working on the same biology. So I'll give you a very quick history. If you remember last time we talked about CT, CT was started in at Mass General. And basically, plastic surgeons took the idea, made metal plates to try to put it on ladies' and men's fat to shrink it. And that eventually became something called cool sculpting. And it's been relatively successful in plastic surgery. But the way in which they apply the technology, so they have their patents, really don't allow it to be completely effective. And they just really did that so that they could make money doing it. And it's still in use today. You can call, most plastic surgeons up and find it, but I find it's much cheaper to do it yourself at home, utilizing ice in a bathtub. So the cooling aspect was one part of the Quantlet. The other aspect came from the Stanford glove. And the Stanford glove, for those listeners who don't know, probably about 10 years ago, there was a bunch of researchers, both at Stanford and Harvard, that took Olympic athletes, and they came up with the idea that maybe they could do something to improve athletic performance if they could effectively change the physics of blood flow in those athletes. So they came up with this device that is a monster. It looks like a huge catcher's mitt for baseball, and it's very bulky. And one of the key things in their patents that they could not get across was they used a vacuum suction device on the hand and the wrist in order to keep the blood vessels open, so they could cool them. And when you look at the device, and anybody who's listening to this podcast can probably go and Google the Stanford glove and look at all the pictures. The problem with the device, fundamentally, if you're an athlete, is that you couldn't wear it when you really wanted to perform because it was just too bulky. But the interesting thing is they did a lot of research on cooling, and it was tied to this Harvard group. So when I started to read all this stuff, 10, 12 years ago, I started to realize immediately something that these guys completely forgot, is that sunlight itself actually could replace the vacuum device. And when I thought about it further, I realized that it didn't have to be full spectrum sunlight. It just had to be certain frequencies of light. And the reason for that is light frequencies are known to actually stimulate nitric oxide release from our skin. And for those of you who don't know, we have tons of nitric oxide that's buried within the surface of our skin, and certain frequencies of light actually stimulate those, and it turns out the frequencies of light with the most kinetic energy are the most effective in doing that. And it doesn't have to be highly powered light to actually get this effect. So that immediately gave me the idea, if I could somehow use light to vasodilate the arterial system in the hand, I could actually effectively make the most amazing heat radiator that anybody's ever seen. So you know how it is when you're like a theoretical quantum biologist back then. It's one thing to have a great idea, but I'm not an engineer. At the time when I came up with this, my son actually was in college, and he is now graduated. He is an engineer. He was very interested in this process, and believe it or not, he actually used the idea in one of his projects in school, and everybody was really fascinated with it. Well, I happened to get lucky. I went to an event that I spoke at, and don't you think an engineer is there? It turns out that he's a former GE light engineer. And when he heard my talk, he was part of this Q&A that was epic. It was like 12 hours long. It went to 3 o'clock in the morning. All he said to me, he asked me one question in this mass of people. He says, tell me about light. And I just said, well, the issue is light is the key. It's especially certain frequencies of light. And then he just said to me, what about red light? And I said, it's absolutely phenomenal because of how our biology is built. And all he said back to me was boom. And that was it. That was the extent. And then literally, I think it was about a week later, this person, Ruben Salinas, reached out to me, and it turns out he lives in Boston. He said, look, I know that you're giving another talk up in Maine next week. Would you mind if I come up and just talk to you more about light? So he did that. And subsequently, over probably the next 2 months, Ruben not only came to hear me talk at other events, but he also flew down to New Orleans to meet me here. And we were sitting on my porch right outside there, looking at my magnolia tree, and I explained to him how a magnolia tree works with the light, and then I explained to him how animals use phototropism. And he was fascinated by this because he understood where I was going with it immediately, that, you know, we're all taught in biology that photosynthesis occurs in plants and bacteria alone. There is a form of animal photosynthesis in us, but the pathway in terms of the way it works is radically different in terms of how the system's set up. So it was at that time that I gave Ruben my idea about the Quantlet in all its details. And I told him what the technical barriers would be to build it. And Ruben said, give me a chance. So he went home, and within 2 weeks, he had a prototype. And that prototype changed about 40 times in the next 2 to 3 months. And then it was about 3 months later, we basically had the final design done. And, you know, we started to tweak and test and move forward. And he flew down here with a provisional device, and we started testing it. And the way we tested it is I had told Ruben about some really novel stuff that was going on in Russia. And I told him that in the States, no one really had a clue how to test this stuff based on the Stanford Glove protocol. So I told him that I think we needed to use gas discharge and light frequencies to figure out how it would work. And that's what we did. So Ruben went out and bought one of these GTV cameras. And that's how we optimized all the protocols on the Quantlet. And we weren't going to give people the protocols initially. We were going to let people biohack them and figure it out for themselves. But because we had a delay in the Quantlet shipping because of this nastiness with the Samsung Galaxy Note 7 and the battery, we had the same manufacturer. So we got put on the back burner because we were small potatoes compared to them. So we decided to give those as part of the package when the device ships. So long story short, we started to do some serious testing with it, and the testing was pretty amazing. And I brought the device to a talk that I gave in Vermont this May, and we actually put people on the GDV before and after. In fact, 4 weeks ago, a pretty famous guy on the internet who's got a very big site, excuse me, also wanted to pre-test the Quantlet. And Ruben flew down there and put it on him, and the before and after for that was pretty shocking as well. And when we begin to explain to people how this device really works, what you begin to realize is that what I said to you earlier, what happened on my porch right over there, was that this is a device that can augment the mammalian battery. That phototropism takes huge advantage of the system that's built in us. And this system, I think everybody knows the independent parts, but this is what makes me a little bit different than most people. I am a connector of facts to make sense of how the body uses it. So, for example, the easiest thing I can describe for you guys to see kind of the method of the madness to the Quantlet is if you go look at an atomic picture of chlorophyll and of hemoglobin, you're going to notice something very, very striking. Both of those molecules are called porphyrins. But the difference between chlorophyll and hemoglobin is one atom at the center. And in chlorophyll in plants that's green, it's a magnesium atom. And in hemoglobin in us, it turns out that it's iron. And when you see the difference, you see that everybody, I think, knows that's listening to this, that red blood cells are red. And I think most people know that chloroplasts are green. Well, it turns out that they're optimized for different frequencies of light because of that single metal atom change in the middle. So it got me thinking about, okay, why is this fundamentally the case, and how can I take advantage of it? And these are all the ideas that were swimming in my head probably for the last 10 years. And once I figured it out, the linkage between chlorophyll and red blood cells for your listeners is basically chloroplasts and mitochondria. What most people don't know is chloroplasts and mitochondria both are endosymbiotic bacteria. We both stole them from different places. It turns out in evolutionary history, 650 million years ago, plants actually stole the bacteria first. And photosynthesis was born in plants. Plants evolved before animals. But here's the key take-home for everybody to know, is that photosynthesis is the basis of the entire food web on the planet. So without the chloroplast, food could never be innovated. So fast forward 50 million years, in that time frame, animals then did the same thing that plants did. They stole the bacteria and turned it into a mitochondria and put it inside cells. So that's where the two kingdoms of life changed. Prokaryotes and archaea, archaea bacteria, added eukaryotes, and that's the most complex cell. Well, this event occurred in something called the Cambrian Explosion. And the Cambrian Explosion was approximately 585 to 600 million years ago. And here's the interesting part from an evolutionary standpoint. Literally, life for 3.8 billion years on this planet was basically archaea and bacteria. And then all of a sudden, overnight, all the phylos of life showed up on the planet overnight. And, back in Darwin's time, he didn't obviously know this, but you have to realize one of the key tenets of the theory of evolution is that it happens gradually by natural selection and conditions of existence. But when you understand this story, you begin to understand that Darwin his theory has a lot of holes in it. This is one of the biggest ones. And the reason why it's a problem is because literally the fossil record is definitive proof today that something magically happened 600 million years ago. And that magic turns out to be endosymbiosis. And many people who are what we call neo-Darwinists, like Richard Dawkins and Jerry Coyne, and I would call these guys religious, even though they're all atheists, they're religious about Darwin's idea. The fundamental tenet that I don't think they understand is that both plants and animals share a common ancestry and a common mechanism when they stole the bacteria and turned it in to something that used light to make energy. And that's really where it all comes down. I basically used that whole story I gave you to really synthesize what the Quantlet is capable of doing.
Right. Okay. So Jack, let's just backtrack a minute. So mitochondria, for listeners, is basically an organelle in a cell that is known to produce energy. It's usually associated with ATP production. But what you're saying is that human beings are essentially photosynthetic, but by a different pathway. So could you, on the subject of mitochondria, could you talk to us a little bit about what a mitochondria actually does? Could you talk about Dr. Doug Wallace, what he's found, and why this may be important for us to understand?
Yeah, I mean, mitochondria, I guess we have to have two different paths. I'm assuming you must be from England, correct?
Yeah.
All right, well, there's a famous guy that won the Nobel Prize in 1978. I think he should have won the prize, but not for what he won it for. His name is Peter Mitchell, and that goes to this whole story. If you open up any biochemistry book, what I would call conventional wisdom idea is that mitochondria basically use electrons and protons in a chemoosmotic couple to make ATP. And the belief currently today is that ATP is the single driver of the enzymatic flux of the 100,000 biochemical reactions that occur in a cell per second. So that's what the dogma is today in modern cell biology. Well, the interesting part of this story is in the 1950s and 1960s, a guy named Gilbert Ling came along in this bioenergetic debate and looked at the amount of ATP a cell can physically make and realized very quickly that if we continue to believe this, that the amount of ATP, there's a huge deficit. And his original paper, I think he said that the deficit was about a 50-fold. He wrote another paper where it was 500-fold. And currently today, we now know that it's about 3,000-fold deficit. So what does that mean? That means if we are to believe Peter Mitchell was completely correct in 1978 Nobel Prize, that our fundamental belief breaks the second law of thermodynamics by a factor of 3,000. So there's another famous Englishman called Sir Alfred Eddington who proved Einstein's theory of relativity. He was an astronomer, and he famously once said, anything that controverts the second law of thermodynamics is pseudoscience. So we have a very interesting conundrum. Even today, when I was in medical school, up until 2016, most people, I would say 99% of people on this planet still believe Peter Mitchell's thesis about chemoosmotic coupling is correct. Now, I believe he's correct, that it's important making ATP, but here's the difference, and this is where Doug Wallace comes in. ATP, in my opinion, is not the main driver of energy flow or enzymatic flux to control those 100,000 biochemical reactions that occur in a cell every second. The key is the interaction between sunlight and water. And Doug Wallace came along about 40 years ago, and he is what we call probably the world expert in mitochondrial medicine in the world. He's currently an MD, PhD geneticist at the Children's Hospital of Philadelphia. Here in the States, we call that CHOP for short. You guys can find him and many of his publications anywhere. But Wallace is unique in the fact that he looks at a mitochondria very much like I do, as a bacterial endosymbiont that basically our cells stole and use to create energy. Now, I will tell you that Wallace still, I think, subscribes to Mitchell's theories, but I don't think Wallace is completely facile with the new data from Pollack's lab and Gilbert Ling's work, where it shows that when sunlight hits water, it basically makes a huge capacitor. And the reason why this is important is, remember, guys, in a cell, every single mitochondria is surrounded by water. And the way mitochondria functionally work, if you open up any biochemistry book, is we have this inner mitochondrial membrane and outer mitochondrial membrane. and then there's different spaces in between. And inside the matrix of a mitochondria is filled with humongous amounts of hydrogen protons. And that means it's a hydrogen atom with the electrons stripped away. And the inner mitochondrial membrane is where all food electrons come. So what your listeners may not know is that all foods fundamentally break down to electrons. And that's not something that most of the, or at least the narrative of the meme is, you know, the ancestral health community, medicine, alternative health. Everybody always talks about macronutrients. And I think you guys probably know I don't. I think anybody who talks about macronutrients to people is somebody who's fundamentally telegraphing that they have absolutely no clue about anything about how a cell truly works. It really comes down to understanding electrons and protons. So it turns out in mitochondria, we have these cytochromes. There's 5 of them. And it turns out where electrons enter actually can tie back to food macronutrients. It also ties fundamentally back to that story about photosynthesis. Why? Because the entire food web on this planet is tied back to electrons being excited by sunlight. And really, when you fundamentally understand what life really is, it is the ability of a cell to capture the sunlight from the excited to the ground state. So what does that mean? It means, well, sunlight excited this electron, and that energy is harvested, and it's harvested by the cytochrome proteins in the mitochondria. And that energy is both coupled in electric, magnetic fields to make hydrogen protons and make water do things that we know are physically true, but nobody's connecting all these dots together. Well, Wallace figured out a long time ago that mitochondria are really special. He's the reason why that we found out that all mitochondria we inherit from our maternal side. He's the guy that actually invented that, and that's part of the reason why I think he's going to win the Nobel Prize probably sometime in the next 10 years. But he took the issue even further. You guys probably all know that the modern narrative in medicine right now is that most things in medicine are tied to genetics. That is what we call neo-Darwinism or genetic determinism. I would tell you that is absolutely the dominant paradigm in medicine, 99.9%. Turns out guys like me, Wallace, and many others, like Mina Bissell, who's an oncologist, we are starting to see serious evidence that almost every disease on the planet is tied to energy deficits from mitochondria. And Wallace is the charge, okay? I mean, we're talking about absolutely leading the charge. In fact, if you go on my Dr. Jack Kruse Facebook page and just put Doug Wallace in, you'll see some videos where they're about an hour long, but when you watch it, it's very dense science. But when you watch it, he basically makes the case in these videos and from all the work he's done that basically that type 2 diabetes and Alzheimer's disease are exactly the same disease. The only difference is how much heteroplasmy turns up in a cell. And what heteroplasmy means is good mitochondria have low heteroplasmy rates, meaning they make a lot of energy. Type 2 diabetic makes less energy. Someone with Alzheimer's disease makes even less energy. And the key factor is the less energy you have has huge ramifications for the protein folding that occurs in cells. And that's the reason why in Alzheimer's and Parkinson's and all those diseases you guys know about, we see these protein folding disorders. Here's the interesting thing that Wallace and his whole crew of scientists have found. The mitochondria itself, the outer mitochondrial membrane, is connected to the endoplasmic reticulum. That's another organelle in the cell, and guess what it does? It controls protein folding. What do we know about protein folding and how this whole story links together? Well, that's interesting too. The first 2 folds of all proteins are givens, meaning they're thermodynamic givens, and we get that from the DNA code. And a Nobel Prize was given for that. We discovered that in the 60s. The key issue is the first 2 folds of proteins are not the most important, because guess where the physiologic effect of proteins come? Well, it comes from the 3rd and the 4th fold. We call that tertiary and quaternary folding. What Wallace has found out is that the outer mitochondrial membrane connection directly to the endoplasmic reticulum is completely tied to the redox potential of the cell. What does redox potential mean? It's that's present in the cell. Another way to put it, how much net negative charge is in the cell to do physiologic work. And this is where water comes in. Because when sunlight hits water, what does it make? It makes a battery. It makes the redox potential. So the more light energy you can turn into an electric current, the more energy a mitochondria fundamentally has. And what Wallace is telegraphing the world is the more energy that's present in a cell, the less disease state you get. So in other words, instead of looking into the genome for the real problem, like looking at all these crazy genes, we need to start functioning, or I should say, functionally looking at the other genome that's in us. And it turns out it's the mitochondrial genome.
Okay, hold up a second, Jack. So basically, just for listeners to really get this, because this is so important, is that what you're saying is that all modern diseases, this researcher, Dr. Doug Wallace, has essentially...
I wouldn't use the word all. Let's just say about, because what Wallace has said publicly and what he said in his papers, about 80%. I'm not going to tell you there's not genetic diseases out there. There is. But the ones that we're concerned about in medicine, most of them are tied to mitochondrial damage.
Wow. Okay, so Jack, if that's the case, then can you talk to us about some of the things that damage the mitochondria? Like, for instance, blue light. How does blue light affect the mitochondria?
Well, to get into that discussion, you do have to know a little bit about how mitochondria work. And I would tell all your listeners, what I think if you want to learn about the nuance of mitochondria, read a lot of Wallace's work, look at his videos online. But I'm going to tell you another guy, and you're going to like this because I'm pushing the UK button here. There's a guy in the UK named Nick Lane who's written a lot of books. And one of the key books I would tell you to go back and read is called Power, Sex, and Suicide. Now, that book is old, but a lot of the data in it is still pretty good. There's some things that have been updated, and his latest update in the book is called The Vital Question. And The Vital Question really gets to the core issue. And unfortunately, I wish I could tell you what page it's on, but Lane stumbled into the key finding that Wallace had. And I'm going to just cut to the chase here and give it to you. The respiratory proteins in a mitochondria they're measured on angstrom distance, okay? And when you go between cytochrome 1 and the fifth cytochrome, which is the ATPase, it should be about between 18 and I think 36 angstroms. And that's what we consider normal for a non-heteroplasmic mitochondria. Anything that stretches, meaning makes the respiratory chain bigger, ruins energy production in a mitochondria. And the reason this happens, Lane never gets into. Wallace does, but I really get into, because that's my focus, and that's where you, I think, jump from the area of biology into physics. And the reason for that is simple. We know that the whole purpose of the respiratory proteins, they are electron chain tunnelers, meaning this is where electron tunneling occurs. Electron tunneling is a physical effect, and it's actually a biophysical effect. And it turns out that tunneling of electrons is much more likely the closer things are together. Well, remember I told you earlier that water is right around the inner mitochondrial membrane. Well, this is the part of Pollack's work and sunlight that most people haven't linked, and even Wallace hasn't linked this yet. What squeezes down these respiratory proteins to keep them shrunk? Well, water does, and I'll give you the key thing that people forget. If you took a beer and put it in your fridge right now, what would happen? I should say your freezer. It would freeze and the can would explode, right? Yeah. Well, everybody knows that water expands when it gets cold, but you know what everybody forgets? When water gets warm, it shrinks. So I want you to think about what else you know that a mitochondria does. It releases infrared heat, doesn't it? And that's the reason why it does. Because when you release heat through the process of energy generation, you're shrinking water to thin or shrink the distance of the respiratory proteins to make it more likely to tunnel electrons to make more energy. So what does blue light do? Very simply, blue light stretches the respiratory proteins. So it's fundamentally really bad. What else does it? Non-native electromagnetic radiation. That's probably the number one issue, and I consider blue light a non-native electromagnetic radiation. And I'm not talking about blue light from the sun versus our electric lights, because those are not equivalent, but I'm talking about chronic toxicity. So, for example, I don't know how old you are, the kid from the UK, but I did a biohack on my patients about 8 years ago, and I asked them to document in one day how many times they looked at their cell phone. The average for over about 1,000 people that I looked at was 150 times a day. Now, my belief is your age group, it's probably more like 300 times a day, because most of my patients are much older than you, and I think your generation is completely screwing the pooch by their use of technology because they don't understand it. And that's one of the number one ways. That's the reason why we're seeing so many serious diseases that I'd see in 60 and 70-year-old people, and now I'm seeing it in kids that are 20 and 30 years old. I mean, it's not out of the realm in my neurosurgery practice that I see somebody come in who's 25 years old that has arterial disease in their neck. And that just shouldn't happen. Well, Doug Wallace has laid out the path of why this happens. And it's because they have heteroplastic mitochondria. And when you really understand Wallace's science, it gets even more interesting because it brings up the point of transgenerational epigenetics. Why? Because we inherit the mitochondrial genome from our mothers. So that means if your mother did some really bad stuff, or she was in a really shitty environment and didn't know it, that means that the baby that you became comes into this world with a higher percent heteroplasmy, and that means that you're already born at 40 years old from a mitochondrial perspective. That means you can't make energy. So when you think about the new modern diseases that have just showed up, like obesity and autism, and the fact that we're now seeing Alzheimer's disease in people that are 40 and 50 years old, you immediately default to Doug Wallace's ideas that this heteroplasmy thing is a variable, it's a dynamic, and it's given to us by the maternal side. So that's why people who come to my site and they want, me to help biohack some of the things about them, the first thing I want to know is their grandmother and mother's history. Why? Because I want to know how they came into this world and what kind of power pack is in each cell. That is probably the key factor in understanding what's going on. And then you start to ask them about their environment, because if they happen to be in an environment that fosters the respiratory proteins being stretched out, immediately why they have the problems they have. And most of the memes and the narratives that you guys probably talk to other people about, like adrenal fatigue and this and that, dude, these are all tied to these factors. And see, notice since we've been talking for like the last half hour, have I mentioned food in any of these things?
Not at all.
You know why? Because it's inconsequential, and I'm gonna try to make this point to all of you very crystal clear. I want you to think about what we just said in the first half hour, just like a Ferrari. Does it make more sense to focus in on the fuel of the Ferrari or the Ferrari's engine in terms of getting maximum performance?
The engine.
Right. And guess what? Where's the narrative in the alternative health world and medicine? It's around food, right? I mean,
yeah.
It's ridiculous. And when you really understand what Wallace and what Lane and what I'm saying, this all is about the mitochondria. So the people who follow me on social media, the people who decide to become members on my site, what am I doing to them? What am I teaching them? I'm teaching them how to be mitochondriacs. And when you become a mitochondriac, your sole focus on just about everything you do in health and wellness is tied to building a strong redox potential by understanding the mechanisms that you were given 600 million years ago at endosymbiosis, and understanding how to absolutely maximize that energy flow in your Ferrari engine. And I have to change the narrative from a food-forward narrative to really an engine narrative. And most people aren't facile with the science of mitochondria. But the cool thing about my job now, it's become way easier because I can literally tell people, go buy this book, read it, then come back. See, that's what makes me a little bit different. All these parts are well known. What's not well known is how the parts fit together. So that makes me not a discoverer of anything. It makes me an innovator because I can connect the threads of how nature works. And, I have a huge amount of respect for Doug Wallace, but one of the things that he's missing the idea about water chemistry. If he knew that, he would immediately get rid of Peter Mitchell's idea. And it's not that Mitchell's idea is bad, because Mitchell was right. The chemoosmosis theory is how we make ATP. But ATP is not the key story. The only thing ATP is beneficial for is unfolding proteins so that you can get to these tertiary and quaternary folds so that they can work optically and magnetically with light. And no one's talking about that. That's the stuff that currently on my blog and currently the members who hear my offline stuff that the public never hears, that's where I teach them about the Faraday effect and electromagnetic induction, how actually blood cells work this way, how healing works this way. That's the stuff that fascinates people, because when you have the basic connections all down, you begin to take, disease processes that we don't have an answer for in medicine, and all of a sudden you say, wow, this is beginning to make some sense. And then when you give somebody a simple little hack to do that's not difficult, they come back and say, hey, guess what? My tinnitus went away. Or, you're not going to believe this, I was able to go from negative 4.7 diopters on my glasses, and I'm now not wearing glasses. And these are things that, like, if you go to the ophthalmologist or you go to the ENT doctor, they're like, yeah, we don't have an answer for that. And that's kind of what you're given, and that's true everywhere in the world. And the point that Wallace really made in his research, and that's the reason why I kind of look at Doug as the guy that really gave me the roadmap of where I need to travel, because he's laid all the basic science down. I'm the guy that's basically showing people the clinical thread that they need to go through to improve mitochondrial function so they can reverse diseases. Because honestly, 80% of the diseases out there, which are the ones that we're most interested in medicine, can be fixed if you understand how to biohack a mitochondria.
So, Jack, you've talked about Gerald Pollack's work and how water, you spoke about on the last show, how water has this fourth phase. It's known as structured water. And the body, when it's exposed to infrared and UV light, this builds the structured water, and this is how we essentially fuel our energetic reactions. Yeah. So what I know on your blog you've spoken about dehydration, intracellular dehydration. Now, if water is a main source or a main means by which we harness light energy to fuel our bodies, what sort of factors affect how we do this with water?
See, and I'm glad that you asked this question, because immediately when you were asking it, I wanted to jump and interrupt you, because you just proved to me that you don't understand mitochondria by asking the question. And I'm not saying this to down you. I want to teach you something right now. I want you to go and look at the photosynthetic pathway and mitochondrial pathway. And I'm talking about from a 30,000-foot level. I'm going to explain it to you very quickly. A plant takes CO2 and water and turns it into glucose. You learned that in third grade. That's photosynthesis 101. Here's what you forgot. What does a mitochondria do? It reverses the process, and what does it make? CO2 and water. Your mitochondria makes water. Think about that for a minute. And you use that water to interact with sunlight. You completely reverse the process. And you know what? You open up any damn biochemistry book, and they will tell you the end part of mitochondrial energy biodynamics is production of CO2 and water. Well, your cell uses it. So here's what you're learning right now. Anything that dehydrates you tells you, if you're a mitochondriac, that you're in an environment that is lowering your energy potential. In other words, something is sucking the juice out of your Ferrari engine. That means it's your job as a mitochondriac to figure out what it is that's doing that. And what have I told people? Instead of looking within for a defect, like a lot of these alternative practitioners do. I'll give you one of my standards. I don't usually say this on podcasts because I don't like pissing people off, but they talk about detox. Anybody who focuses on detox and not redox is an absolute they're telegraphing. They don't know anything. And the reason why is for what I just told you and how a mitochondria works, because it creates water. So anything that creates water, I mean, nature is telegraphing us that Pollock and Ling and all the water researchers that are out there have been right. The problem is PhDs are really good about knowing a lot of shit about very small details. You know what they're bad at? Connecting the dots. And unfortunately, I have to say, probably physicians, we're the guys that are supposed to connect the dots, but the problem is we don't learn enough of the whole connecting thing to actually be able to do that. And I guess what I'm trying to tell you is that me focusing in on Nick Lane, Wallace, Pollock, Ling, all their work, it became very obvious to me what we were missing. And we were missing the details on what mitochondria do. So when you begin to see that a mitochondria creates water, doesn't use it, you have to start asking yourself, why would Mother Nature do that? Is there a reason? And I already gave you the reason earlier in this podcast. Why? You need that water to go around the respiratory protein so that when your mitochondria releases infrared heat, it shrinks the proteins to increase energy production. Everything is coupled, my friend. Everything. And our job as modern humans, as far as I'm concerned, is to understand that natural design, that quantum design. And when you do, all of a sudden, you take the idea of carbohydrates, proteins, and fats and just throw them in the toilet because it's a waste of time talking about it. And that's part of the reason that I guess I'm controversial, because my perspective is wholly different than just about anybody else you're going to talk to.
So what can a person do if they want to become a mitochondriac? What are some basic things that they can do to make their mitochondria function better?
Well, read. Some of the things we talked about here, I would tell you probably the fastest way is probably become a member of my site, because this is my sole focus. You know, when you realize what Wallace has really put out there, if you are a sick modern human, you need to learn as much as you possibly can about mitochondria and about how to biohack, your environment. Well, guess what? You guys started this podcast off. You want to talk about the Quantlet. Guess why the Quantlet's been in my mind for 10 years? Because functionally, what does it work on? It actually works on improving mitochondrial energy flows. And the way it does it, I mean, I could sit here and talk to you for 2 hours, but I'm not going to do that. The amount of science that's gone into this is astronomical. And a lot of the science is published. The problem is people aren't reading it. Instead, you know what they're doing? They're, pulling Jimmy Moore's book out and seeing how nutritional ketosis is, working for him. Well, that's a waste of your freaking resources and time. And all of us, our most valuable asset is time. So if you continue to listen to people giving you the wrong message, guess what you're going to get? Nature has a plan for you. It will take you out. And unfortunately, most people who are going to listen to this podcast, they may not want to invest the time. And this is what makes me also a little bit controversial, even within my membership. I don't believe everybody can be saved. Why? You have to have a passion for yourself. See, if you're not good enough for yourself, who the hell are you good for? And I tell everybody, wellness always begins as an N=1. And when I say N=1, I'm talking about your mitochondria. You have to have a passionate love story with your own mitochondria. And once you tap that energy, people around you are going to sense your passion, and they are going to want to learn this. Those are the people I focus in on. The people who are swimming towards me, I'm interested in. The people who just have a passing interest, say in this podcast, you say, oh, that's kind of interesting stuff. But they never invest the time. They have no skin in the game. Dude, I don't have time and energy for that. Those people, to me, are energy vampires. If they want to do what they're doing, let them do it. Mm-hmm. But for me, I cannot waste my time on people that have a food-forward narrative. I am going to teach people where their focus should be attuned, and that anything has to do with mitochondria is where it goes. And the fundamentals of mitochondria, which, Tiffany, you asked me fairly clearly probably 5 minutes ago, and I didn't give you an answer. It comes down to three things: light, water, and magnetism. Yeah. Now, that's very simple to say, but when you want to learn about the details of how those work, that's when Jack Kruse explodes your mind.
Right. So, Jack, on your blog, you just said a minute ago, you said about redox before you detox. And there's, in the alternative health community, that those guys rave about heavy metal detoxes. They use things like DMSA and other chelating agents. But I'd like you to just briefly touch upon calcium efflux. What is calcium efflux? How does it affect the cell? And what can we do about that?
Well, calcium is a little bit different because it's part of the cellular design. It's the secondary messenger system in a mitochondria. So it controls a lot of the electrochemical and electromagnetic gating reactions, meaning that I guess the best way to describe it would probably be an air traffic controller, say at Heathrow. And that person has to do a good job in order to keep some order in the cell. So, for example, all non-native EMF, we've known this literally since the 1960s from a guy named Alan Fry, and it's been recapitulated and reconfirmed recently in 2009 by somebody named Volkow, that any type of non-native EMF, that means outside of the sun and outside of the magnetic flux, causes calcium efflux. The science is so deep in this area, and most people don't know about it, that they use ion cyclotron resonance to prove that this, in fact, occurs in all cells. So anytime you happen to be in an environment that is non-native, it causes your loss of control of this calcium-gated phenomenon. And when you do that, you break down the electrochemical gradient. So what did I just say? Complex words. You lowered your redox potential, meaning you have less net negative charges and more positive charges. What do we call that in medicine? What's the scale up? Anything that's inflammation is a positive charge. That means a low pH.
So
what do we
proton.
know? Right, exactly. And we're back to protons again very quickly. Now, what do you know about Pollak's work? Let's scale all this together, because I know we're jumping back and forth, but I think it's kind of important so you guys get how facile you need to be with this. Low pH means low EZ. High pH means higher EZ. See, even water has an electrical potential because it's tied to the amount of protons in it. What do you know about the exclusion zone when it's built? It excludes protons, okay? That's important. Why? Because where are all the protons, guys? In the middle of the mitochondrial matrix to spin the ATPase. And when the ATPase spins, anything that spins, we're back to the UK. Remember that guy, Michael Faraday? That's the Faraday effect. You induce a magnetic field. How do we know this is true? How do you guys know that Jack Kruse isn't a complete wingnut? Well, if I put you in a meg or a magnetotron, I can find huge magnetic fields coming from your heart and your brain. Want more proof that it's true? What did Faraday say? 90 degrees orthogonal to any magnetic field, you'll find an electric current. So what do we call an electrocardiogram? So I can put stickers on each one of your chests now and show you electrical deflections of the ATPase in the mitochondria in your heart. And we've been using that in medicine for over 100 years. No one questions that. You know what the problem is? They have no idea what generates it. And guess what it generates? It comes from a mitochondria. That's effectively what we're looking at. So these physical laboratory tests that we use all come back down to electrons and protons. The problem is you don't understand how that happens. My job is to teach you that. That's what a mitochondriac does.
More questions, Elliot? He's been inhaling the stuff on your blog.
Yeah, well, I'm also really interested to hear your take on dopamine. I know that you've spoken a lot about dopamine on your blogs, and I'm just interested to know how does dopamine affect the rest of the hormones in the body, and how can we work to preserve our dopamine stores?
Well, dopamine's a very complex story. And I'm going to try to make it easy for you. You know that dopamine is what we call a biogenic amine. It's related to serotonin, melatonin, histamine, things like that. In other words, they have some basic structure. The basic structure has a ring. It's a hexagonal ring that's made out of carbon. And it's basically known, like if you open up a chemistry book, what we would call a benzene ring. Do you know what's important about benzene? Benzene absorbs all frequencies of light between about 200 nanometers all the way up to close to 280, sometimes 300. This is strongly UV range. So, what do you know about dopamine? Any place it's found in the body, you can usually find some melanogenesis, meaning that darker pigmentation. What do you know about dark when it comes to physics? Anything that's dark absorbs more light and releases it more quickly. So basically, dopamine has a ring structure in it that is a playground for photons, meaning that the photons enter, but they're captured. So one of the key places that most people know about dopamine, and unfortunately I'd like to change this narrative, but I don't think I'm going to be able to, is everybody knows about the substantia nigra and dopamine with respect to Parkinson's disease. But what they don't realize is the first place that you make dopamine that gets to your substantia nigra starts in the eye. And it's through a part of the eye called the retinal pigmentum epithelium. And if you Google RPE and Jack Kruse, put it in a Google box, you'll be overwhelmed with how much information I've written about the eye. Why? Because it turns out the eye and the skin are the single two most important ways that we absorb and assimilate light to create dopamine. Now, what does dopamine fundamentally do? It does a lot of different things. But the number one thing, and I think you guys will like this since we're tying a lot of loops here. Remember we talked about chloroplast and mitochondria and their linkage. Well, if you took a chloroplast from my tree right outside here now and looked at it, it has a circular or hexagonal cell where the chloroplast is in there. And if you put UV light on it, it spins way faster. The same exact relationship is present in the RPE in the eye. You took UV light like this one right here. And I know you guys probably can't see it, but you guys may be able to see me. That's UV light. All right, and you put it right on your eye, you can actually find with time-lapse photography that the RPE spins faster. Well, what did I tell you before about anything that spins faster? It induces a magnetic and electric current, doesn't it? So that's how you build the redox. So what dopamine does in the eye, it goes through the central retinal pathways, and the central retinal pathways go straight to where the leptin receptor is, okay? They also go to the suprachiasmatic nucleus. They also go to the frontal lobes. What separates humans from chimps? Our frontal lobes. So we have massive amounts of dopamine in our frontal lobes. What do you guys know about people who don't get enough sunlight? They get depression. They get seasonal affective disorder. Like you guys are from the UK. If I put you in Glasgow right now and you'd probably be depressed by January. And the reason why is because you're at the 59th parallel up there. You're not seeing enough. And people don't realize the first place you make it is in the eye, gets generalized to the frontal lobe, then it goes to the pituitary, then it goes to the substantia nigra. So now I want you to think about what I told you about Wallace. What did he say? That as mitochondrial damage goes, then you get a disease. Well, the first disease you get in your eye is called myopia. Then myopia sets you up for AMD, which is acute macular degeneration, which is poor vision. What happens then? Well, you know that suprachiasmatic nucleus that runs all your circadian programs are right there. So if you have less spinning, that means you have less electric current working the circadian clock, the main clock that controls every other one in front of all your genes. That's how you die. Okay?
So is this just due to a lack of UV, or is this caused by other types of light?
Oh, no. It will spin, and we know that different frequencies of light induce different spinning in both chloroplast and in mitochondria. And that's the reason I told you before that I hope your listeners who are listening to this go back and look at what chlorophyll and hemoglobin look like together. And you'll notice the difference. And what's the main difference between magnesium and iron, my friend? The number of electrons. Here you're getting another lesson about physics. How does the photoelectric effect fundamentally work? The electron density means there is more probable collisions. That's the reason why animals were more complex that are designed to move across the tectonic plates use iron, not magnesium. Why? Magnesium has 12 electrons in its valence shell. How many does iron have? 26. So if you are a more complex life form and you wanted to have a better Ferrari engine, that's the reason why we chose iron and not magnesium. And it turns out that magnesium chlorophyll, magnesium porphyrin, which is chlorophyll, actually is optimized for blue-green light. Turns out that hemoglobin is optimized for UV light. And that's the reason why the spectrum of hemoglobin goes all the way down to 280 nanometers. So that means you can absorb more light energy on a per unit basis when you look at hemoglobin versus a chloroplast. But that doesn't mean that plants cannot use UV light. We absolutely know it can. In fact, and I know your listeners probably won't know this, but I forget what today's date is. But if you guys have the benefit, if you go look at my Dr. Jack Kruse Facebook page, last night before I went out to dinner, I published something about how UV light in plants has homology with some of the things in humans. And it ties all the way back to chromatin. Remember, what is chromatin? Things that make DNA coil back up. You see, my goal is to keep showing people homology between chloroplast and mitochondria. Why? Because this all is a mitochondriac story. And that's the key. If you want to really understand plants well, you have to become a chloroplast maniac. It's no different. And I will tell you that the more you understand about plants, the more you'll understand about animals. Why? Because the way evolution built us is we stole our Ferrari engine from a bacteria, and we turned that bacteria into something that functionally is a frequency shifter of light to harness as much energy from sunlight as possible. And the more energy that you harness from sunlight, the less you need from food.
Okay, so Jack, would you, I know you haven't got much longer, but would you be able to just quickly touch upon biophotons? The book by Roland Van Wyck, Light in Shaping Life. Could you explain a little bit about what the findings that were presented in that book, and why we may need to top up on the UV light? Say when we live an indoor lifestyle, especially here in the UK, it's cold outside. What ways can we do to mitigate this as well? Well, lack of sunlight.
I can give you a brief overview, but I would tell everybody, once you become a mitochondriac, at least I tell my members, that book you have to buy and you have to begin to read it. It'll take you probably 5 years to truly assimilate all the data that's in there. But that book goes all the way back to the original studies in the early 1900s that basically show you that we are creatures of light. In other words, we absorb light. Now, humans absorb it through their skin and their eyes. So when you understand that every functional program in you, those 100,000 biochemical reactions that we talked about an hour ago that work every second in your body are controlled by light frequencies. And the amount of light frequencies, just so we're clear, we have 81 followed by 36 zeros in the visible spectrum between 260 and 700 nanometers. So the power, the range of the visible spectrum to control 100,000 biochemical reactions is easy. And all biochemical substrates have specific spectra associated with them, meaning that a light frequency works best with that. And that's true of both dopamine, histamine, anything that neurotransmitters are made of. This is all the stuff that's in this book. It tells you how it connects. But here's the key. When you understand that we are beings of light, that means we have to have ways to collect the light, use the light, and we also leak the light. And we proved that we leak light in the 1960s. A guy named Fritz Popp, who you'll read about in this book, was a physicist. He wasn't a biologist. He basically invented something called a photomultiplier. And he started to put cabbage, leaves, normal things that you would find in the UK laying on the ground now in a photomultiplier. And he started to realize that all things in nature that are alive release light to different degrees. He even took it further. He put bacteria and compared it to eukaryotic cells. And one of the things that he noticed immediately is that things made out of bacteria release more light, 5,000 times more light than eukaryotic cells. So when you hear that and you start going, that's interesting. A mitochondria came from a bacteria. What does a mitochondria release? Releases red light. So you begin to start to see all this. And one of the things that Popp showed is that people with Neolithic diseases like cancer release more light from their eukaryotic cells. They're much more like a bacteria. Popp made the linkage immediately to maybe cancer is a mitochondrial disease because we're releasing more light. In other words, we're not retaining it. Wallace has said the same thing, but from a biologic perspective. We now have data that proves it. So if you look in the last probably 4 or 5 chapters of that book, I think most of you listeners will be shocked to see that the nails on their feet, the nails on their fingertips, and their face is designed to release huge amounts of light. So the reason why humans like to kiss, hold hands, and the reason why you guys would probably like me a little bit more if we were really meeting each other instead of doing it on the internet, you would actually be able to sample my biophoton release so that you would actually get another dimension of the passion that's buried inside of my mitochondria. And notice I'm not laughing. I'm being dead serious. You don't think that we have the ability to sense that, but your mitochondria does. And your mitochondria is truly your sixth sense. It is a sensor for the electromagnetic spectrum, and we pick up all those nonverbal communication abilities that we know humans have but we can't explain is tied to this type of science. And it turns out the number one thing, I guess, the take home for the book that you need to understand is the difference between bacteria and us is we are designed to retain as much light as possible. So in other words, when our mitochondria get sick, we release too much light. And when we release too much light, none of the systems in our body work. And that's part of the reason why you have to reconnect. You have to look at the sun as a wireless solar charger. And in order to be plugged in, your feet or parts of your body need to be connected to the earth while you're in that sunlight. And if you happen to live in a really bad environment, let's say like Edinburgh, in say a university, constantly under blue light because you want to become the next great quantum physicist, you are actively releasing tremendous amounts of light from your body, and you live in an environment where you can't refill it because you're at the 59th parallel. So if you were a really smart guy and understood everything that's in Roland Van Wyck's book and everything that Wallace is trying to teach you, you would take a plane directly south to Mallorca, or if you're more gamey, maybe to Morocco, and refill maybe 1 week every 2 months. And your system is so sensitive to these factors that could help you offset your ability to live at a very high latitude with poor light environment. And, we're doing this podcast, right close to the winter solstice in the northern hemisphere. People in the southern hemisphere are coming to the summer solstice. These are ways that you could actually biohack your mitochondria. So, for example, and you guys don't know this, but 3 weeks from now, I'm getting ready to go to the 20th latitude with 50 members from my site to talk about these kind of things, to talk about how this idea is built into that Quantlet device, how these things, they're congruent. In other words, they're correlated. This is how you take the science that's published and begin to use it to actually functionally change your mitochondria and shrink those respiratory proteins so that you can do the things you want to do. Because the more you understand how to make yourself energy efficient, the less that you'll get wallet bopsied by guys like me.
Well, we wanted to ask one last question. You've written a little about this on your blog. We wanted to ask about nicotine. Did you have something more specific, Elliot?
What's nicotine's effect on the mitochondria? I know you recommend supplementing with nicotine to some people, either by nicotine gum or patches or whatever, but I'd like you to explain what effect it has on energy production in the body.
Well, I wouldn't say that nicotine is something I recommend. It's actually a biohack. So, a lot of people that are my members, part of the reason they become members is once they start an optimal journal on my website and I get a background, of basically what kind of mitochondria they got from their grandmother and mother, and they tell me a little bit about their story, you can actually begin to give people ideas about how to go from a high heteroplasmic state to shrink it down and then improve it. Because remember, we have change programs in us that I think most of you guys know. It's called autophagy and apoptosis. So the people who live the longest are the ones that understand how to maximize those two change programs in mitochondria. Well, nicotine happens to be one of the ways to do it, and it's not for everybody to do, because you need to make what we call a superoxide pulse at cytochrome 1 in order to stimulate the change programs. It's called mitophagy, autophagy, and apoptosis. They're all different ones. And like I said, we could spend another hour just talking about those alone. But for your listeners, the basics, when you become a mitochondriac, you will understand what those programs are immediately and understand why you would want to use it. Because you have a high, just for argument's sake, heart failure is when your heart doesn't pump blood effectively. It means to a mitochondriac that the mitochondria in you are like a Nissan Sentra from 1984 and not a Ferrari that just came off the line. So your goal is, unlike the car, you can never turn a Nissan Sentra into a Ferrari, but you come with two programs in you that actually can turn your mitochondria back into a Ferrari. If you find out that you have a high heteroplasmic state, you can induce those change programs to improve your mitochondrial energy flow so that when you go back to the doctor, he can actually see changes on your EKG, changes in your ejection fraction. You'll see changes in your blood chemistry. All of those things will move you the correct way. Nicotine happens to be one of those things that restores the free radical pulse or the stimulus of that change program that mitochondria use. Now, it's not appropriate for everybody, but it's one of the things that people can biohack once they assess where they are. So another chemical that you could also use, and this is what people use who have really bad mitochondria, like someone with heart failure, is methylene blue. Methylene blue is very similar to nicotine, except it makes bigger pulses, because people who have really shitty mitochondria, like someone with heart failure, need a bigger free radical stimulus to get from a senescent mitochondria state to one that can undergo autophagy, or one that can undergo apoptosis and then mitochondrial biogenesis. And if you look in the cardiac and neurosurgery literature that's published, online, you'll find that many cardiac surgeons, when they do heart surgery, are now injecting methylene blue into their patients, because almost anybody who has their chest cracked open for heart surgery, by definition, has a heart that's got really shitty mitochondria. And what have the cardiologists and the cardiac surgeons all found? That people that they use methylene blue in, they have remarkable recoveries compared to those they don't. The problem is they don't understand why. They just know that it works. So the reason they don't understand why, guys, is what I told you earlier. They're not mitochondriacs. And when you become a mitochondriac, you begin to understand why you can read about these amazing things in the literature, but nobody's tying the loose ends together. That's kind of how nicotine and methylene blue work. And to do your own biohacks, I personally think, especially when using these things, I personally think that you need to have a lot of basic mitochondrial information. And I don't talk about this stuff publicly because, to be quite frank with you guys, if you're not, a mitochondriac, you're not part of my team, I'm not going to make any kind of recommendations publicly, because I think you can hurt yourself when you don't know what you're doing. And that's part of the reason why I have a huge problem with the biohacking community in general, because they look at the latest new whiz-bang thing and they don't understand how it works and they don't understand how to test it. And to me, that's extremely dangerous perspective to come from. But I think when you really understand how a mitochondria work, then you become a citizen scientist. You become, I'm actually trying to get away from the term biohacking, but it's so popular, it resonates with people. I like the term citizen scientist because we now have things out there in the public domain. In fact, I haven't talked about this publicly, but I'll mention it here. I've taught my members through private webinars actually how you can use CRISPR-Cas9 kits that geneticists are using in laboratories to actually understand what your heteroplasmy rate is in your mitochondria in your own body. And when you understand how to do that, then you can decide, hey, is nicotine smart for me? Is methylene blue smarter? or maybe I just need to use the pulse of carbohydrates to induce the change programs. And that's the kind of sophistication in mitochondrial biohacking that I get my members to. It's not something I talk about publicly because I think people can hurt themselves until they know really what they're doing. And unfortunately, most of the people, that are probably listening to this, as far as I'm concerned, and this may be my cognitive bias or what some people may think, may call me an asshole for saying this, but I really believe this, is that you have to have skin in the game. And if you don't have skin in the game and you're not willing to focus in on mitochondrial energy dynamics, then I don't believe you have any business using nicotine, methylene blue, or anything else, until you really understand what you're doing. It's almost akin to me saying, hey, I'm a dermatologist, but I'm going to do brain surgery on you. That's crazy. And I think the data is out there. I think there's enough published where I can lead a person who's interested and teach them to become a citizen scientist very, very quickly, because it becomes very easy when you know what to look for and know what not to look for. And, the problem with our modern world right now, especially podcasts and the NIH and PubMed and all that, we create so much data. But you know what the problem is? You need to know what data is reliable, what data is good, what data you should focus in on. And that's one of the big problems, I think, with medicine today. We have so much papers I think there's 4 papers published a second in PubMed. Well, how is a citizen scientist going to cut through that level? PhDs can't even stay up with the level of science. And the problem is it becomes easier when you know what matters and what doesn't. And that's kind of what I teach people.
Well, it looks like we are running a little past our time. So in order for our listeners to become citizen scientists and mitochondriacs, they need to focus on light, magnetism, and water. And they need...
I would say first, truly, before you do that, I think you need to get a library of books. We mentioned a lot of them here today.
Roland Van Wyck, Nick Lane.
Right. I would tell you Wallace's videos online are great. He's got tons of papers that are out there. You'll also see a lot of people on Wallace's team, Jody Nunnery, Vamsi Mutha. You'll see all these names out there. Pollock's book, Ling's work, Martin Chaplin. You guys must love me in the UK. Martin Chaplin is over in the UK. The chap that you guys would like in the UK is Jim L. Khalili and John Joy, who wrote the book, Life at the Edge. If anybody who listens to this think that quantum biology is not happening all around them, go read their book and your mind will be blown. And I know in the BBC series over there, we don't get it in the States, but Jim L. Khalili has done some amazing videos that I would tell you guys to link to your listeners and say, guys, he does an amazing job in a BBC video where he actually shows how proton tunneling occurs, and he uses one of those castles that I can imagine Led Zeppelin used to, do a lot of their recording in, and the ball is really big and red, and it just gives you a huge visual of actually what's happening in the mitochondrial matrix as all this goes on. And you sit there and go, okay, I got this. Because, most people are visual learners, especially when they're not facile with the science. But I will tell you, at least what I've learned with my members, as soon as they get the basics, it grows like wildfire. Some of the people have been with me 4 and 5 years, they are unbelievable. And I would also tell people, if you want to learn fast, jump in the deep pool. Go on my website on the forum, because I have a forum that's completely free. You're going to meet tons of members from all over the world that have been with me for a while. We love people to ask questions. You know why? Because that's a sign to us in my community that you're trying to swim towards us and not away from us. And anybody who swims towards us, we're going to throw you a life preserver, and we're going to direct you in the right, region. But I think to become a true mitochondria, before you get to the 3-legged stool of light, water, magnetism, you got to read a little bit.
And we'll put those links at the bottom of our show notes. Is there any particular blog post that you've written that you can name off the top of your head that would be good for people to familiarize themselves with?
I would tell people, if you want to jump in, read the Redox 1 blog, because we talked a lot about redox here, and redox really is the fundamental key to becoming a mitochondriac. I also have a Redox 2 blog that's about MRIs that I think people would be interested in. But I would tell you, if you want to jump into a series that is down the pike that actually may tie into a lot of things that you guys asked me about today, I would say the ubiquination series, starting with ubiquination 1. I think there's like 28 blogs on that. Then it jumps right into the time series. And the time series is some really cool stuff. I just jumped into a new series just in the last couple of weeks called Reality. And Reality 1 and 2 are published on the site. And it also ties to this podcast, because in Reality 1 and 2, I show you how to evaluate a food guru. And if they don't talk about excitons, then you have no business listening to them. Why? Because excitons are the basis of photosynthesis, and photosynthesis is the basis of the food web. So if they're truly a food guru, they need to know about excitons. And in 2 blogs, and they're not very dense, I think you can learn about this process. And not only that, remember we talked earlier in this podcast about looking at chlorophyll and magnesium. I think in both of those blogs, there's at least 2 or 3 pictures of that side-by-side of chlorophyll and hemoglobin together. And I lay out in very stepwise fashion how that plant photosynthesis occurs. And actually, I don't think I've laid out yet how it happens in us, but there's a lot of foundational work that's going to teach you that. I think starting there would be good, and read those books. Some of my old stuff, if you want to cut through the first probably 3 years of my blog without actually reading it all, I would just tell you to go buy my book on Amazon. I think the book does a really good condensed job, and it's about 250 pages.
That's the Epipaleo prescription, or RX.
Yeah, and it cuts through really the first 3 years of the blog, and those are what I call the baby steps when you decide to step into the deep pool. The really cool stuff, the biophysics stuff, it can be found on the blog for free, but it's dense. I'm not going to lie to you. I'm assuming that you've already read some of the books that we talked about here, because if you haven't, you're going to do
They require additional reads because they're dense too.
Yeah, spend a lot of time reading it.
You're going to probably be on Wikipedia going, what the hell is a quasi-particle? But that's good, because I actually enjoy that, and I actually glad you guys brought it up, because to me, as a person, when I see people are invested in that, and it's kind of like I give you guys kudos here right now. You guys called me back up and said, Jack, let's do another podcast. That tells me something about all 3 of you, that there's something from that first hour we did that intrigued you, and that's really what, as far as I'm concerned, a surgeon or a doctor should be, as a teacher. It's my job not to tell you what to learn. It's my job to point you in the direction, and then it's your job to decide that you want to learn. And when you do, when you make that jump, that's when I consider people part of my tribe. That's when I'll go to the end of the earth to make sure that everything I know is planted in your head. Because, 12 years ago, I didn't know any of this stuff. If you guys would have met me 12 years ago, you would have never invited me on a podcast.
Well, there really was a time, like right around the time when we interviewed you the first time, I was like nuts about trying to find everything I could about mitochondria, but it was such a brain-splitting topic. It kind of like fell to the wayside after a while, but I'm going to try and get back into it more, because I kind of really like a lot of what you're saying, and I think that if we knew more about mitochondria, we'd be better off for it.
No doubt. It's kind of the way nature works, and I always tell people that at my core, everything I stand about is nature. I want to know how either evolution or God, whoever you believe in, how things are organized so that life can do the things that it does, because there's no greater story on this planet than understanding that, because the more I go, the more astounded I am of just what an incredible creature Mother Nature is. It is just, I could talk about it all day long. There's not a day that goes by that I don't find out something new. It just knocks me off my feet. And that's, to me, the key. I don't care about, like, the emotion or anything tied to it. I care about natural truth. And that's, I guess, sometimes it can come off, especially on social media, as being arrogant about certain things. But I have such a focus in on learning about those things. I don't really care about anything. Before I die and they put me in the ground or burn me, whatever the hell they're going to do with me, I need to know more. I feel like I wasted the first 40 years of my life, and I am so lit on fire about this science because not only did it change my life, it changed my family lives, but it's changing people in my practice life. And the application of the science is not that hard. I always tell, the old Southern ladies that want to avoid surgery for osteoporosis, I said, look, all you got to do is make like the Sphinx. And they look at me and they're like, you're kidding me. I said, no, I need you to take your shoes off, sit on the porch, drink your coffee, and look in the direction of the sun. So that's exactly what the Sphinx does every day. So if you do that, you can stay away from me.
So if someone wanted to learn more about the Quantlet, where could they go?
Right now, probably just the Quantlet website. There's it has its own site at thequantlet.com, but there's also still a page that's open on the Indiegogo site because that's where we originally opened it for crowdfunding. But obviously, you can't buy any of the beta units; they sold out in like 30 minutes. But there's still a couple available. They'll be shipping in about 4 weeks. The other thing I do for members, like, for example, 3 weeks from now, I'm going to Mexico with 50 people, and I can tell you, all, at least from what they've told me, all of them want to talk about the Quantlet. So when I do private events, that's usually where we start talking some deep stuff about the Quantlet and mitochondrial medicine. That's stuff that you would find out if you were a member at my site. And, I have free memberships. That's bronze, and then it goes silver, gold, and platinum. You can look into that. If you want access to me, you have to be either a silver, gold, or platinum member. And I do monthly webinars, and I have to say, and this is going to sound totally like I'm kissing my own ass, but if you want to really learn about what a mitochondria really works, I'll give you, your readers or listeners, a plug. I would tell you to go and listen to my April 2016 webinar, where you'll hear me talk for 3 hours straight with almost not even taking a breath about how a mitochondria really works from a perspective that I guarantee you'll never hear anywhere else. It will absolutely blow your mind. And those webinars actually have Q&As after them with my members. And if I'm not mistaken, that Q&A was almost 3 hours long. And that's what you get in a monthly webinar. And every month is a different topic. For example, in December, because we're in December now, I haven't done the Q&A yet, but what did I talk about? The Q cycle in mitochondria and how it works. So we took this one little part of a mitochondria and completely exploded it so that people understand functionally what the Q cycle is and what coenzyme Q10 really does in your body and why statins really have a bad connotation from a mitochondriac perspective. That's the kind of stuff that I do. And a lot of times, if a member has a really good idea and wants me to talk about a topic, we'll get into that. And I did that live for people recently. I wrote a blog post called CPC 13. It's called the hypoferritin cataract syndrome. And, this is a syndrome that's extremely rare. But I became interested in it after the person brought it up on a Q&A because I felt that it was important for people to understand ferritin from an electromagnetic perspective. So you don't even have to be a member. You can go and read that blog, and you'll learn a shit ton about ferritin, its magnetic abilities, and also how it works with infrared light. Things like that. I try to really engage with my members, and if there's something they specifically want me to talk about, I usually will do it. But usually every month it's a different topic. And I cover a whole bunch of different things.
Well, now we know what to get Elliot for Christmas.
Well, that April webinar, I guarantee you guys, I'm not kidding you. You listen to it and just sit back. Do not take any notes. Just listen to it the first time. Because my wife did. She actually sat for an hour and a half. She goes, that was crazy. and to be honest, I don't think I could ever recapitulate that. I mean, when I tell you it was a complete vomit of everything I know for the last 12 years, and I did this on a dare. One of my members said, you need to tell everybody what the last thing you ever wrote, in this series of blogs is. And I thought about it, and I said, you really want the last one? And they're like, yeah, because we want to know what the target is and kind of where you are now. It'll tell us kind of the road. And I thought about it for a while, and I'm like, do you really know what you're asking? And of course they didn't, because, we're unaware of what we don't know. And I said, okay, I'm going to do it. And I did it. And I will tell you, to a man, I haven't seen a member yet who's listened to it. But if you think you know a lot now after listening to this podcast, I will promise you listen to that one, and you'll have a complete different perspective of truly what a mitochondria is.
Okay.
There.
Yeah, it's a dare now. Well, unless anybody has anything else real quick, I think we'll let you go, Dr. Kruse. Thank you so much for coming back for part 2. It's always great to have you on the show. I've listened to a lot of your other shows that you have spotted all over YouTube, but it's great to have you for our own for an hour and a half. So, yeah, we'll put all of the links in the show notes. You can check out Jack Kruse at jackkruse.com. His book is called The Epipaleo RX, or The Epipaleo Prescription. And you can also check out the Quantlet at thequantlet.com. So thanks again, Dr. Kruse, for coming on the show. And thank you to all of our listeners, and thanks to all of our chatters. And we will see you next week for another episode of the Health and Wellness Show.
Take care.
Okay, bye.
Thanks, Jack. Bye.